This is going on page 13 when we're done, right? We're going to talk about relations and functions, which is way back, review stuff. Even Ms. Tremont came in today and was like, what are you talking about this stuff in pre-cal for? So just because I want to make sure we're all on the same page moving forward, okay? So definition of a relation. All a relation is a set of pairs. Okay. We have relations and we have functions. All functions are relations, but not all relations are functions. So an example would be -2, 0, 4, 3, 7, -5, whatever. So that would be a relation. It's some sort of set of ordered pairs. It could be an infinite number of ordered pairs, but there you go. So there's different ways to represent them, and these are all things that you have seen before and that we are familiar with. The first one is a table, of course. So it could be like -2, 3, 5, -2. These numbers really could be anything. The table of that represents a relation. This oval looking thing that I know that you have seen before. So if I have like -2, 0, 3, 4, 6, and 8, something like that. And then, so you've seen this, right? Can anybody tell me what that type of representation is called? No. And it's okay. I'm not going to quiz you on vocabulary, but it is important to be able to recognize it and like when you hear it or see it, so that when it tells you to do something and uses that word, you know what the heck they're talking about, right? Well, here what's happening is negative map. So this is the mapping representation. Then we have the graph. Don't worry about exactly where I'm putting my points. I'm just putting some random points on here, so there's no need for you to count on that tiny grid and try and make it exactly like mine. Just put some on there. And then the last one is an equation. So we could have y equals -3x squared plus 7. Okay. We all good so far? Nothing new and shocking, right? Like, it's all stuff we've seen before. Domain and range. Now, you can talk about that since Algebra 1 or maybe before also. What I'm really concerned with here and why we're going back over it is to make sure that you're notating it correctly. There's no doubt in my mind, if you're in the right place anyway, that you can talk to me about domain and range and tell me those. What I see the struggle with the most, even though you've done it year after year, is for some of you, the way you notate it. Okay, so we got to make sure that our notations are correct and accurate. So domain is the set of all possible what? Okay, so set of all possible x values, but the and that's a true statement, but we don't necessarily have to use x, right? It could be a, b, or q, or whatever. So what's another way to talk about that variable specifically, no matter what letter it is? Okay, it is horizontal, so it's your left and your right, and you're right. Okay, how else? What? Independent, good. So these are the independent variables. Okay. Then range is the set of all possible y values, or what do we call these? Dependent, or that's your vertical, right? It's good to know which way to go. So there's different ways to notate it. So we're going to look at the types of notation real quick. There are times where you can use whichever type of notation you want. There are times when you're told to use a specific notation, or a specific notation is used for you and you have to be able to read it correctly to know what we're talking about. So I kind of want to define them specifically here. And so by doing that, one of them is going to be a little weird, but we'll talk about that in just a second. We're going to use just the parent function of a parabola. We're going to write the domain and the range in 3 different ways. So the first thing that we're going to do is inequality notation. There are things in math that are very specific, like it is done this way, always done this way, and nobody argues about it because that's the way it has to be. Then there are things that people are still arguing about what's the right way to do it. Now, if I asked you and I didn't tell you a specific notation or anything, and I said, what is the domain of that graph? What is it? All real numbers. And that is a true statement. All real numbers, though, is not, and I can't write, if I just write all real numbers, that's not inequality notation. The problem with inequality notation when you're trying to do all real numbers is that when you write inequalities, you're really not supposed to use infinities. But there's really no other way to do it for all real numbers. So inequality notation isn't used most of the time when you would have something like all real numbers. It's used more when you actually need the inequalities. But depending on which textbook you look at and who you want to argue with and that sort of thing, you can write it in inequality notation. It would look like this, okay? But this is the only time that you use infinities with inequality. Trying to do that. The range, okay, what would the range look like in inequality notation, do you think? Okay, except we don't use the infinities, that's the thing. Okay, so all this would be then is that y has to be, is it greater than 0? Or what? Greater than or equal to, yes. So I wouldn't go from 0 to infinity. Does that make sense? Because you don't use the infinities. The only time you ever would be here. And honestly, if you look up, because I tried to look at all these different places. We were having this big discussion about this notation last year. And most of the time, this type of situation is just avoided when it's explained. So this is what your inequality looks like. And you're way more likely to use this when you have actual numbers there that make sense. All right, so now let's do set notation. So for set notation, the domain is all real. Technically, it should be x as an element of all real numbers, something like that. But this is okay. It's kind of a shortcut. But range, set and it would look like this, because you have to use this when you're doing the set, right? X, it's set of all x's such that x, oh, I'm sorry, it's x, I'm in range. Holy cow. It's just the second week of school. Second day. I don't even know what day it is. There you go. So it's y such that y is greater than or equal to 0. That's what I meant. Then the last one, the domain, I start way out here, the smallest x value. Infinity. Do I use infinities? Is infinity included when I do this? No, you never include it because it's not actually a number. So these are parentheses. The range, the smallest y value I have is 0, and then I'm going to go all the way to infinity. Never include the infinity. Everybody okay with all that? Yes, yes? Okay. So let's do some of these. We're not doing all of them, but on numbers 1 through 3, it just says give the domain and range of each relation. It doesn't say in what form. But when you have a finite number of points, your only option is set notation. Inequality doesn't make sense here. Nothing else makes sense here. So we are using set notation here. Right? So it's a set. The domain is just the x values. I've got -1, 7, 3, and -5. Well, the smallest one is -5, then -1, then 3, then 7. There's my domain. Yes? The range is my y's of -1, 4, 0, and -1. So -1 shows up twice. Do I write it twice? No, I do not. So this is -1, 0, and 4. Any questions about those? We're good, right? All right, let's look down here. It says give the domain and range of each relation in inequality notation. All right. So for my domain, the first x, starting with the smallest, the first x I get is -3, and then it goes all the way to infinity, which means that x has to be what? Greater than or equal to -3. Good, because that's inequality notation. So then my range, the smallest y value, what? Good. Y has to be, is it greater than -4? Or greater than or equal to? Good. Everybody okay with that? Now this graph here, we've got these things here. What are these things called? Asymptotes. Yes. Unless you ask Mrs. Archer, then they're asymptotes. But they're asymptotes. So they're asymptotes. So my domain, I'm going to go from -infinity to, is that 3? Which means that x has to be less than 3. I don't get to include it because I have an asymptote there, right? But then I start over, and I also get all of them that are greater than 3. So I could say just that x cannot equal 3, but that's a set notation type of speech. Does that make sense to you? It's an okay way to say it when you're not told what to do, but just saying x cannot equal 3, that's more of a set notation. So then my range, I'm going from -infinity to 0, which means y has to be less than 0, and y has to be greater than 0. It just can't equal 0, basically. Okay? So when you have more than one inequality thing, you use the word and, or like just and. I was kind of being a little sloppy there, but that's what that is if you can't read my handwriting. It's just an and symbol. You could use the word and. Any questions at this point? Alrighty, flip it over. And let's see. All right, so this time it says give the domain range of equation in interval notation. Right? So on number 7, the domain is all real numbers, right? But for interval notation, that means I'm starting way out here at -infinity, going all the way to infinity. Do I include them? No, I never do. So who would? Can another word come out besides okay? -5 to what? 5. Do I include them? Yes. So it's brackets. It's -5 and 5 are well y values that exist. Okay. All right. Number 8. So we've got a whole, right? It's on this line, but one is missing. The one that is missing here is -1, -3. Okay. So my domain then, I do start way out here at -infinity. Don't include it. Go all the way to -1. And it's not included because there's not a point there, right? Then I start back over at -1 and go to infinity. What goes in between those two? The U-looking thing, yes. Because it is a union of those two intervals. So it is not a capital U, right? It kind of looks like one. It's more like a rounded V. The little tail thing is. It's like a capital U without the little tail. Okay, so make sure you're not doing something weird there. So in my range, I'm going to start down here at -infinity, go all the way up to -3. There is no -3 y value. Then I start back over at -3 and go to infinity. Okay, everybody okay with that? All right, so now number 9. Domain. My x's start way out here where? -infinity. And then the biggest x value I get is 0. Do not include infinity. Do I include 0? Yes. What's the smallest y value? -infinity. And what's the biggest one? Infinity. Good. All right, let's jump to 12. So I have a hole here, which means my smallest x value is at -4. Do I include the -4? No, because there's an open circle. Then the biggest x value I get is 1, and there's a bracket there, right? Because I do include that one. So then my range, what's the smallest x value you get? I'm sorry, smallest y value. Oh, -7. Do I include it? Yes. Okay, when I'm going up and looking at my y values, is this whole going to be a problem for me? Okay, so there, right here, this point right here, which is at is it -4, -3? Yeah, at -4, -3, that point does not exist. But this point right here, does it have a 3 as a y, -3 as a y value? Yes, it does. So even though there's a hole there, I still have a continuous range because there's a point that's right here. Does that make sense to you? Sometimes that's confusing for me. So we go all the way up to 2, and I do include them both. Okay. Yes? Okay. Good deal. All right, so that's relations in general, and all that stuff applies to functions as well. So now function, here's your definition. A function is a special type of relation. So again, in which each element of the domain, which means your x's, is paired with exactly one. That word exactly is very important. Element of the range, which is your y's. So if you have a set of points, or you have a graph or whatever, what is to be a function, what can repeat? X's or y's? Y's can repeat. So if you look up at this right here, this is a function, right? And this y value of 5 repeats over and over again. But every x value only has one y. So x's cannot repeat. So when you're looking at sets like this and it says determine whether the relation is a function, well, I'm going to look at this. Do you have any x's that repeat? No, then it's a function. It's not asking you what the shape is or anything. It just, is that a function? So on number 14, do you have any x's that repeat? Yes, even though it's written just once, that -9 is paired with -2, and it also maps to 5. So since this repeats, this is not a function. So you look at 15. Is 15 a function? Yes, the 8 repeats. That's a y, so that's fine. It's still a function. Okay. We also know the vertical line test. And even Ms. Tremont was even like, they're doing this in Algebra 1 today. I know. I'm just talking about it quickly and moving on. We're not teaching it. But you could also call it the pencil test. So this is something, again, from Algebra 1. I drop a vertical line down here. It only intercepts once, so yes, it's a function. 17, it hits it twice, so it's not a function. Is 18 a function? Yes. Okay. All old news, right? Nothing new and surprising, or nothing's changed, right? Okay, grab your other piece of paper. We're going to do some of this too. This is going on page 14 when we're done. So we have explicit equations and implicit equations. And again, hearing that vocabulary and knowing it is important. I'm not going to give you a vocabulary quiz, but you can't be like, think that you've never heard this stuff before. So explicit equations are solved for a specific variable. Doesn't matter which variable it is, but it's solved for a variable. You have like y equals 2x minus 5, or it could be x equals 3y squared plus 4, or whatever. Okay, so each one of those is solved for a variable. Then implicit equations are not solved for a specific variable. So it could be like x squared plus y squared equals 7, or y minus 3x squared equals 8, whatever. Doesn't mean you can't solve it for a variable, it's just not. Okay. All right, so the directions here say write each equation explicitly in terms of y, then indicate whether the... So let's look at number 1. I want to solve for y. So the first thing I'm going to do is move my x. So negative 4y equals 20. At negative 4, so we get y equals negative 5 plus 1/4 x. Okay? So I have it solved for y. If you want the 1/4 x first, that's fine. It doesn't really matter. But here it is. I solved for y. Now, is this a function? Yes. When you graph it, what's it going to be? It's going to be a linear. It's a line. So all lines that aren't vertical are a function. So this is a yes. Okay. All right. Let's look at number 3. I want to solve for y. So the first thing I'm going to do is move my x over. So this gives me y plus 1 quantity. Now this y plus 1 squared, I don't need to square it. If I did square it though, does it give me y squared? Okay, so right. Take the square root of both sides. So this is going to be plus 1 equals the square root of x. I'm not finished solving for y, but tell me what I'm missing. Plus or minus. And that will be a huge downfall for some of you. Some people will miss that every single time. Don't be that person. If you introduce the square root, you absolutely positively have to put in plus or minus. Okay? So then I can subtract 1 from both sides. So I get y equals plus or minus the square root of 3 plus x, and then minus 1 on the outside. Now, unlike the linear one, you may not just have a picture in your head of what this is going to graph. Maybe you do, maybe you don't, but you won't always. So instead, you got to think, I know that x's can't repeat. For every x I have, I only get to have one y value. If I substitute in, let's say up here, substitute in 4, right? So 4 times 1/4 is 1. I add it to -5, I get -4. I'm getting one answer. It's a function, right? Well, here, and we'll make it easy, we'll substitute in 6. 3 plus 6 is 9. So I get plus or minus the square root of 9. So I get plus or minus 3 minus 1. So how many y's do I get? 2 for that one x, right? Is that an okay thing for a function? No, because that would be 6, and then whatever the answer is, and then I'd have another 6, and I'd have those 2 different y's for one x. Then my x repeats. Make sense? So that's a big no. So that makes this no, not a function. That's how you can think. All right, let's look at number 5. I'm trying to solve for y, right? So you could do this in a couple of steps, but what I would do when I look at this is I know the 8 can be subtracted over here, and then this whole thing can be added over there, and it kind of fixes my signs. So I'll do x minus, oh shoot, sorry. I'm not leaning on the board again. So x minus 8 equals the square root of y plus 1. Be plus or minus? No, because we didn't introduce that square root. It was already there, right? If it's already there, you just do whatever it is. So what I need to do now? Square both sides. So I'm going to get x minus 8 squared equals y plus 1. Now I don't have to square. Okay, so I need to subtract my 1, and I'll get x minus 8 squared minus 1 equals y. There is your equation. Is that a function? Yes. If I graph that, what is it going to look like? Parabola. So this is a yes. Okay. What questions do you have? Anything? It's a review, right? Even if we're knocking cobwebs off so we can push forward, right? All right, so then function notation. Again, I mean, this is way basic here. Explicit functions are frequently written using function notation. So if I have y equals 3x squared plus 7, that can be f of x equals 3x squared plus 7. We know that y is just f of x, right? And it reads f of x. We're good with that, right? All right, we're skipping 7 and 8. So flip it over on the back there. We are going to look at 11. All right, so on 11, and it's pretty easy, but there's a reason I want to do this. I want to find q of negative 15. Remember, no matter how easy something is, your first step should always be to substitute it in and do zero work. Okay, you will cut down on your careless mistakes so much. I want q of negative 15. That's equal to the square root of 6 minus 2 times 15. Even if it's easy and you could do work, just substitute it in. Boom. Okay, then we can clean it up, and I don't care if you skip steps. But this becomes 6, and what's net? What 6? Then what? Plus 30. Good. Which gives me the square root of 36. So should that be plus or minus? Do I get 2 answers? Because we didn't introduce the square root. It was already there, right? So q of negative 15 is equal to just the positive 6. So easy question. I just wanted to talk about that square root thing because I don't want you to be confused as to when you do the plus or minus and when you don't. I also don't want you forgetting it. All right, we're going to do 13 so we can talk about it. So I want f of 4. That's equal to 5 times negative 3 to the 4th power. Can I multiply 5 times negative 3 right here? No, big fat no. Aunt Sally says no. Okay, I know there's a new and improved MDOS or what, I don't even know what it is, but it makes no sense. But it's please excuse my dear Aunt Sally. Sally's the one we still talk about. Okay, so we have to do those exponents first. So go ahead and take negative 3 to the 4th power. Figure out what it is. I'll give you a second to do it. And if you're freaking out because you don't use calculators, you don't get to use them in on-level pre-cal either. So just get over yourself. We're going to teach you how to think math. And it's very important to me that you are mathematical thinkers. I'm going to help you think about this stuff in the easier way or the more efficient way. You should not have, it's fine to do scratch work, okay? Don't misunderstand me. But you should not have just scratch work all over your paper. Not because I don't want your paper or anything, but then if you're doing that, you're doing it the hard way. That's my point. So if you will listen to me when I try and talk you through how to think more, number sense wise, it will benefit you tremendously, I promise. So everybody got enough? So at least we should know that this is, I know you know this, but I'm writing it out anyway to talk about something else. So this is what we're doing, right? And there's different ways to approach it. You can multiply 3 times 3 and get 9, and then 3 times 7 and going. That's fine. How many of you did that? Raise your hand. It's not wrong because it's all in how your mind works. Maybe your mind works faster that way and it makes sense to you. That's totally fine. But for some people, those numbers get bigger, especially if I had like to the 5th power, 6th power, it's like that's a lot of numbers. You can do it that way, but you can also look at it like this. Well, first of all, it's to an even power, so we know it's going to be positive, so we don't have to worry about the sign, right? 3 times 3 is 9. So you get that, and then what's 9 times 9? 80. Really, this is just 5 times 80. This isn't crazy hard either. Break it up by the digits. So 5 times 80 is 400. And then 5 times 1 is 5, so it's 405. And it's really not that bad. And I am absolutely positively not saying everything should be done in your head. Nothing with writing down, it's that 400 and then that's 5, so you keep the numbers in your head, or writing down some. Okay. All right. Anybody know what time we get out of here? Dang it. 55? It's 55. Okay. Sorry, I forgot to look and I haven't thought of it since May. So we got plenty of time. So we're not going to do that many more. Let's look at 16. So this has a variable in it, negative 5c. So g is 3 times negative 5c minus 10 over negative 5c plus 5. Okay, I just substituted in. Now I'm going to clean it up a little bit. This is going to give me negative 15c minus 10 over negative 5c plus 5. Can I cancel those c's out? No. Or the 5s or anything? No. Can I reduce this fraction? Yes. But first, factor out the GCF in the numerator and denominator. So in the numerator, I'm going to go with a negative 5. That's going to be c plus 2. You could have done a positive 5 also, but then in the denominator, negative 5, and then c plus 1. No, c minus 1, sorry. The wrong thing. C minus 1. Now can I cancel some stuff out? Yes, now I can cancel out those negative 5's. G of negative 5c is equal to 3c plus 2 over c minus 1. Can I cancel the c's out? No. The plus and minus is like glue. It sticks it together. You don't get to cancel stuff out. You can only do that when you've got some multiplication going on. So that is your answer right there. Okay. We good? Reminders about weird things we mess up on sometimes. That's why we're doing those things. All right, number 17. Now I have a binomial. Anytime that you substitute something in with more than one term, use parentheses, even if they're not already there for you. So when I substitute it in here, this is going to be 2 plus 7 squared minus, and then in parentheses, 2a plus 7, and then minus 1. When I square this first one, I'm not just squaring this and squaring this, right? It's this. And so you do FOIL, you do whatever it is that you learned. I don't care. There's lots of different ways to do it. I'm not going to make you just need to be able to multiply that correctly. That's all I care about. When you do that, this is going to give you 4a squared plus 28a plus 49. Then I'm going to distribute that negative, so that's minus 2a minus 7, and then minus 1. And if you're not already there, you need to get to the point where you can write it out and think about it pretty much just as quickly as I just did. It comes with practice. Okay, so, oh, good Lord. All right, so I've got 4a squared plus 26a, right, because I've got this and this negative. And then this is negative 8 and a positive 49, so it's plus 41. And so this is h of 2a. Okay. What questions do you have? Dang it, it's 20. Oh, wait. Here it's 28.
It's 26.
It's 26. Sorry, dang it. No, I was. Yeah, why? Because this was negative, this was positive. Thank you. Anything else? Okay. All right, so this last part, to make sure we are understanding what's being asked of us. So it says, using the graph to the left, find each function value. The value of the function is the y's. Okay, that's the value of the function. So when it asks you for f of 1, well, we know that this is the x. So the value of that is the y. When x is 1, y is what? Negative 9. Values. Basically, that function values is always asking you for the y or the dependent variable part of that. So y'all fill in these three here while I hand out the assignment. Here, 0, 6, and negative 8. Yes? Okay, awesome.